Well, there's some information that's absolutely critical to complete this course in pre-calculus or trigonometry. And these trigonometric facts, if you will, or properties. And the first starts with the unit circle, and I've drawn the unit circle here. So just as a reminder, and I've shown really 5 angles, 0 degrees or 0 radians, which is equivalent to, if we go another revolution, 2 pi radians. So that's, of course, right here. And then the angle of 30 degrees, which is the same as pi over 6 radians, the angle of 45 degrees, which is the same as pi over 4 radians, angle of 60 degrees, which is pi over 3 radians, and of course the angle of 90 degrees, which is pi over 2 radians. Now, what's important is to remember. How you remember, it doesn't really matter, but what the coordinates of each of the appropriate trigonometric points. And I guess the very first one would be the point we see here, and we know that the coordinates are 0, 1, because this is a unit circle, a radius of 1. The point that the angle pi over 6 transcribes on the unit circle has a first coordinate of the square root of 3 over 2 and a second coordinate of 1/2. And the point that the angle pi over 4 transcribes onto the unit circle has the same coordinates. They're both square root of 2 over 2. And of course, the point that we have when the angle is pi over 3 has a first coordinate of 1/2 and a second coordinate of the square root of 3 over 2. And of course, because again, we know this is a unit circle, this is the point 0, 1. Now remember why it's important to know all of those, because the first coordinate is the sine function, the cosine value of that angle, and the second coordinate is the sine value of that angle. So here's the next, let me draw a table to put these things together, and quite frankly, I don't use the table as much as I use this diagram in my head. Okay, you see I've built a bit of a table here, and across the top I want to put the angle values. I called that row theta, and the angle values, of course, can be in degrees or radians. So on top I'm going to put 0 degrees, and under that, that's the same as 0 radians. And then I'm going to have 30 degrees, and under that, of course, that's pi over 6 radians. And then I'm going to have 45 degrees, and that's pi over 4 radians. And then 60 degrees, and that's pi over 3 radians. And then 90 degrees, and of course, that's pi over 2 radians. And we could go 180 degrees. I mean, we could build this further. I'm just looking at the first quadrant. And then we fill in the row for sine of theta. The sine of 0 degrees or 0 radians is 0. The sine of pi over 6 or the sine of 30 degrees, as we've discussed by looking at the point, that is the number 1/2. The sine of 45 degrees or the sine of pi over 4 is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2, and the sine of pi over 2 is 1. And then when we look at the cosine of those same angles, the cosine of 0 radians or 0 degrees is 1. The cosine of pi over 6 is the square root of 3 over 2. The cosine of pi over 4 is the square root of 2 over 2. The cosine of pi over 3 is 1/2, and the cosine of pi over 2 is 0. Now you can recall, and of course we could build this for other functions, but you can recall building a table in this fashion to remember those, because those are critical, or you can remember looking at the unit circle and making your decisions on what values those are. But one way or the other, you have to know the sine and cosine of those particular special angles, because they extend when we start looking at angles that are outside of the first quadrant. Well, we also need to know the basic identities. Let me rewrite those. Now, the basic identities are the identities where the other 4 trigonometric functions are defined in terms of sine and cosine. So, for instance, one of the basic identities is the tangent of theta can be calculated by saying it's the sine of theta divided by the cosine of theta. The cotangent of theta is defined as the cosine of theta divided by the sine of theta. Now, those together bring up an additional piece of information that the tangent of theta or the cotangent of theta are reciprocals of each other. So we could say the cotangent of theta is the same as 1 over the tangent of theta. That can be useful sometimes. Next we have the secant of theta, and the secant of theta is 1 over the cosine of theta, and the cosecant of theta is 1 over the sine of theta. Those four identities are absolutely critical. And then we saw in the last few lessons, we've seen a couple, these are actually called Pythagorean identities, but one of them we saw was sine squared theta plus cosine squared theta is equal to 1. And we also saw that the tangent squared theta plus 1 is equal to secant squared theta. And furthermore, we saw that 1 plus cotangent squared theta is equal to cosecant squared theta. Now, all three of those are important, but these two are absolutely critical. And the four above here are absolutely critical. We must know those and be able to state them without any hesitation. Now, we also saw it's important to understand the signs, S-I-G-N, of each of the trig functions. So, and the way we did that is we looked up here, we kind of imagined the 4 quadrants, okay? Imagine the 4 quadrants. Although we didn't draw you in a circle, we imagined the quadrants. And it's just based on information we know about the first coordinates. Anyway, this is quadrant 1, of course, quadrant 2, quadrant 3, quadrant 4. And we're referring to the fact that when we have an angle that terminates in one of these quadrants, we know the signs of the trig functions. We know that the sine of a theta, an angle that terminates in quadrant 1, will be positive. We can say is positive, okay, by saying greater than 0, but we mean positive, don't we? And we can say the cosine of an angle that terminates here is positive. And of course, then the tangent of theta would also be positive. In the second quadrant, the sine of theta would also be positive, but the cosine of theta would be negative. And the tangent of theta, of course, would also be negative because we would have positive over negative. In the third quadrant, the sine of theta would be negative, less than 0. The cosine of theta would also be negative, less than 0. And the tangent here would be greater than 0 because it would be negative divided by negative. And likewise, in the fourth quadrant, we would have the sine of theta being negative, less than 0, but the cosine of theta would be positive, greater than 0. And so the tangent of theta, being the ratio of those two, would itself be negative. It's important for us to be able to think through that very quickly as well. Now, what else did we say? Oh, there was another important information, piece of information. Regardless of the angle, the sine of theta will be greater than or equal to -1, or less than or equal to +1. It will be between -1 and +1. It can't be any larger or any smaller. Likewise, for the cosine of theta. The cosine of theta will always be between -1 and +1. Always. There's no time we can get a cosine value that's 2. No way at all. Now, for the other trig functions, that's not the case. But for sine and cosine, it certainly is the case. And I think that gives a pretty good summary. Now, it certainly doesn't encompass all the things that we have to be able to do to manipulate these, but these are the critical pieces of information we need to know to go further. And I would like to make a note over here. This identity, sine squared theta plus cosine squared theta equal 1. You know, for example, just as for example, now remember it's theta in both of those. So what this says is sine squared of 21 degrees plus cosine squared of 21 degrees is going to be equal to 1. But it doesn't say anything about sine squared of 21 degrees plus cosine squared of 57 degrees. See, it doesn't say that. The angles are not the same, and so we cannot say that that's going to be equal to 1. In fact, it would not be equal to 1. So recognize in these three identities at the bottom here that the angle theta is consistent throughout there. If we have different angles with sine and cosine or tangent and secant, then those are no longer true. So good luck on your homework.